Hello guys, so today we'll be talking about this circuit right here, and this circuit consists of so many components, or let's say some components that I'll be listing them, talking about its use and what's the circuit about. So now the name of the component is um or the circuit. Okay, sorry. This circuit is a one-bit arithmetic logic unit. That's ALU. So the components of the circuit, we have the input and the logic gates, we have decoder, we have multiplexer, we have output, and the use and its functionality. And its operation selection, that's the upper section. Then we have the multiplexer. So I'll start with the name. As I mentioned earlier, it's a one-bit arithmetic logic circuit, ALU. And the components, I'll start with the input. A, we have the one bit. B, we have the one bit. Then the C in, we have the one bit carry in for additional or subtraction. Two one bit control input for the decoder labeled 00 on the right side, suggesting a 2-bit input for operation selection. We have the one bit in, that's the sub, so one bit input, likely a control signal for subtraction. We have the multiplexer or the mult, that's one bit input, likely a control signal for multiplication. And we have the, maybe I'll say div or dive or anything. That's one bit input, likely a control signal for division. Now we have the logic gate. That's also under the component. So that's logic gate for arithmetic or logic operations. That's the X or gate. So using the full ADA portion, that's the A, B, and A, those things. Then the AND gate using the full ADA portion, that's the A and B. Then we have the OR gate using full ADA portion for carry out calculations. We have the X OR gate, that's the D1 and D3 and D2 with the D3. These appear to be part of the selection logic for the marks, or the MUX, possibly controlling which arithmetic results is passed through based on the decoder output. Now the decoder, a 2 to 4 decoder labeled DECD takes the two control inputs and generates 4 unique outputs, one for each operations, as add, sub, multiply, and divide. Now the multiplexer, a 4 to 1 mux takes, or a 4 to 1 multiplexer takes 4 data inputs from subtraction, multiplication, division, and addition, and the addition operation output, and select one of them based on the control signals from the decoder and possibly the D1, D3, and D2, D3 XOR gate. Now output. An output labeled 0, that's the top right, which is the selected arithmetic or logic result from the marks, or let's say MUS. And still under the output, you have an output labeled 1, that's the bottom right, which is the carry out, that's the C out, from the full ADA portion of the circuit. Now the use and functionality. This ALU is designed to perform several basic arithmetic and logic operations on two one-bit inputs, A and B, controlled by a 2-bit operation selection input. Now the full ADA, that's the lower section of the circuit involving AB, that's the carry in, the two XOR gates, and an AND gate, and an OR gate implement a 1-bit full ADA. The output, AB, and the carry in, that's the top part, is the sum bit for addition. The output, that's the A and B, and C, B, and carry in. Bottom part is the carry out or the C out labeled 1. Based on the addition, 1 and 0 labeled 00 moves on to addition. This sum bit is likely the add input to the MUX, or let's say max. Operation selection, that's the upper section of the circuit. A 2-bit control input labeled 00 on the right feeds into a decoder. The decoder converts these 2 bits into 4 distinct control signals, each corresponding to a specific operation. Now the 00 is addition, the 01 is subtraction, the let's say 10 is multiplication, or let's say 10, then 11 is division. So now the subtraction, multiplication, division input to the max, or let's say MUX, suggests that external models not shown in detail will perform this specific operation. The result from the addition the sum bit of the full adder is also input into the MUX, or let's say max, or the multiplexer. Yes. So now the third one, or the last point, the multiplexer. The multiplexer selects one of the 4 operations results based on the decoded control signal. The output of the multiplexer, that's 0, is the final result of the choosing operation. The D1 and D3 and D2, D3 XOR gates likely refine the selection logic for the multiplexer, possibly acting as intermediate control signals derived from the decoder outputs to control which inputs get passed through. So right now, in essence, this 1-bit ALU can perform addition, subtraction, multiplication, division with a specific operation determined by the 2-bit control input. Is provide the carry out from the addition operation. So all I want to say is the 1-bit ALU can perform that's addition, subtraction, multiplication, and division with a specific operation determined by the 2-bit control input. So with the input, then you can have the output, the output. So that's everything about this circuit. Thank you guys, and I'm not feeling well though. That's why you see the tissues in it.